So I guess before I get into stuff on mobile specifically, stepping back for a second, the main issues we tend to see in usable security tend to just stem from two different areas. So one is that users are confronted with so many different security decisions that they become habituated to all the security decisions in the future. The second problem that we tend to see is that oftentimes the security decisions that developers ask users to make, users are just completely unqualified to be making those decisions. And there's a lot of stuff that we can learn from looking at the classic hazard avoidance literature. So looking at the hazard avoidance literature, there's sort of a hierarchy of interventions. So the best thing you can do when faced with a hazard is simply eliminate that hazard so that people don't encounter it. Sometimes we can't do that. So the next best thing is to guard against the hazard so that people are less likely to succumb to that hazard. And then only in the worst case, when none of that is available, we use warnings. And too often we see in computer security that we jump to just using warnings when there's probably a lot of other things that we can do, such as doing a better job of eliminating hazards or helping users make better decisions without just throwing information at them and asking them to click either one of two buttons. So to give you an example of some of these decisions and how it has to do with mobile, one common threat is SMS charges. So a lot of malware on mobile devices will, in the background, send pay per text messages which could run up someone's phone bill. So maybe a user gets a phone bill for several $1,000s all to maybe one number, and now they want to look at their phone to figure out what application might have called this. So on Android, what you would do is open up your applications. You get this list of applications, scroll down to Settings. From there, click Settings. Now you have to find the application button. You click that, and then Manage Applications, click there, and it lists all the applications installed. Then you go through every application. You click one application. It brings up this application settings. You have to know to scroll to the bottom to the permissions, and now it shows you all the abilities for this particular application. So there's a joke about this being a 12-step process. Somewhere in here. But imagine, user has to do this for every single application that's installed in order to figure out which one might be the one that's sending the offending messages. So this still isn't really going to tell them with any certainty. It's just going to tell them the subset of applications that are granted this ability. So there are better ways of doing this. So what I was going to talk about is how choice architecture and how we present these different mechanisms, security and privacy mechanisms, to end users has a profound impact on how they care for their information and how they're aware of what applications might be doing with their information. So mobile security is really interesting because it's sort of become the primary computing platform for a lot of people. So in this country, half of people have smartphones. Well, I talked about malware in this example with an unwanted app maybe sending SMS messages in the background. This actually happens pretty infrequently, and instead the much bigger problem that we see is grayware. And by grayware I mean applications that a user outright installed and wanted on their phone and sees some benefit from having, but that might be doing something unexpected in the background, such as leaking some of their personal data, which might make them feel uncomfortable. And so in this talk, I was going to talk about some of these problems and how the architectures on these mobile systems have a lot of problems with making users aware of how personal information might be used, and how a lot of this stems from the specific permission mechanisms that each platform chooses to implement, and how having a lot more thought in terms of granting permissions might actually improve these scenarios. And also how, to eliminate the habituation problem, maybe in some cases we just shouldn't give the user the option to approve or deny these permission requests. And then in the cases where permission requests are probably necessary, how we can design these interactions better so that when people are getting these warning messages about how personal data might be used, they can make a much more informed decision. So looking at current problems, some of the early work I did in this area was looking at Android. So in Android, when you install an application, at the installation time, the user is presented with a list of all the abilities that that application is requesting, so the permissions. And there are over 100 of them in current versions of Android. And so when they install an application, they get a bunch of these little boxes that say, things like this one is requesting internet access, but you can imagine lots of other ones, such as, maybe vibrating the phone, sending text messages, taking pictures, that sort of thing. And the user is then faced with the decision of, continue to install, thereby granting all these abilities, or, discontinuing the installation. So we wanted to look at comprehension. So do users actually understand what these things mean? And also, when they're presented with each of these permission requests, do they understand what capabilities they're then granting the application? So we did a comprehension survey. We did this online. We used AdMob to recruit people. And so AdMob is a mobile advertising platform. Thereby guaranteeing that everyone who was participating was on an Android device, which means that, ostensibly they're familiar with Android. So we wanted existing Android users. So we had about 10 of these permission requests, and we randomized them so that every participant got 3 of them at random. And we just asked them, we showed them a screenshot, and we asked, if an application is granted this, what does that enable the application to do? So in this case, we have network access, and so the correct answers here would be loading advertisements and sending information to the application server. And from this, what we found was that on average of the 3 questions, people got half a question correct. And so you might say, well, this was online, it was unsupervised, maybe they were just randomly guessing. Well, we can, calculate the expected value of random guessing, and then do a chi-square test. And we find that, despite this being relatively low, it's still significantly higher than the expected value, which is, I think, roughly about 0.2 questions out of the 3. That said, there were only 8 participants out of the 308 who managed to get all 3 of them correct. The majority of participants couldn't answer any of these correctly. Again, these are existing Android users. So there is some room for improvement here. We did this online. This was completely quantitative, and so we wanted to do a follow-up laboratory experiment to get the qualitative data on why comprehension was so low. We recruited 24 people from Craigslist to come in, and we had them do 3 different tasks. So one was we just had them install 2 different applications of their choice. We gave them scenarios, and so to search through the online store to pick applications based on these scenarios, but other than that, we gave them no guidance on what applications to install. And we observed them to see whether they would pause on that permission request screen to try to read it, or whether they would choose to discontinue installing the app based on that screen. And then finally, in the 3rd task, we had them open up the settings panel on their device for an application of their choice that they use regularly. And then looking at those, the permissions that were granted to that application of their choice that they use regularly, could they tell us whether or not that application has the ability to send SMS messages? And so what we found was that during the installation task, fewer than 20% of our participants stopped at that screen to actually look at it. We suspect this is probably an upper bound because they were in the laboratory, they knew that they were being observed, so maybe they did the task with a lot more diligence than they might at home. And then in the other task about answering the question about could the app that they're familiar with send SMS messages, a majority of participants couldn't answer that question correctly, even though they were looking at the list of granted permissions. Yeah.
The 17%. How did you measure that? Is that you just looked at whether people spent more than 0.5 seconds on the screen?
Yeah.
Or something?
Whether they so basically people were habituated to just clicking through. So when you install an app, there's an install button, and then that screen comes up right after you click install, and there's another button in a similar spot. So, over 80% of the people just sort of clicked twice to go right through that screen. And when we asked them, afterwards, they said, oh yeah, they thought that was just like a license agreement. So they know to skip past that.
Sorry, was this a self-report or was this you observed?
We observed them. Yeah, so they were in the lab, and then we were sitting next to them as they were installing applications. So based on the qualitative results, we had a couple suggestions on how the user experience could be improved. So one was that people were just habituated to seeing these requests with every app installation, regardless of what the risks associated with those permissions were. So too many requests. So maybe users should only be prompted when absolutely necessary, when there's an actual risk. Many people were simply unaware. So again, the screen appears after they click the install button. Many people thought that that was just sort of a license agreement, and that they were supposed to click through it. There are also many cognitive biases that might have might have been at play here. So maybe choice supportive bias after clicking the install button. They didn't want to revisit that decision that they just made to install the application. And so maybe presenting this information at a different point in the interaction would have yielded different results. So maybe before they click install, it shows the permissions. Or maybe at runtime, when the data is actually needed by the application, maybe then would be a better time. The last problem was that we observed with the SMS thing, when we had them use an application that they were already familiar with, the reason why most of them got that wrong is that they saw things like a request for network access, and they didn't know that there was a separate permission for sending SMS data. They thought maybe that's part of network access. And so in this case, there's so many different permissions that really knowing the entire set of permissions is necessary to know what permissions an app is not requesting. And when you have 100 some different permissions, that's obviously unreasonable. So, in this case, there are many different ways of granting permissions on mobile devices, and this also applies for desktop platforms as well. In the case of Android, there were there are install time warnings. This is how it appears in, I guess, the more current versions of Android. The advantage of having the install time warnings for doing the permissions is that it's adaptable to a great basically every permission. You can do this because you're just you need a little space for text here, and you have the text to describe the permission. It's also useful for granting future abilities. So these are granted at install time. The application can then use that ability anytime in the future because it's already been granted. The drawbacks to this, they're mostly that there's the limited real estate. So, on your average device, it's about these dimensions. You could really only fit 3 different permission requests on that screen. You're then relying on the user to know that they have to scroll down the screen to view additional permissions. And so those are easy to overlook. Also, when this is part of the installation flow, it's also easy to overlook because there are a lot of other decisions that they're making at that time. And the last problem is that they lack context. So when you're granting future abilities, you have no idea in what sort of situations these abilities are actually going to be used because it's at install time. So when an application, say, asks for location access in install time, maybe to some people that would signal location-specific features, which might be desirable, but it could also mean maybe behavioral advertising is being done based on location, which is something that people might find undesirable. When it's done at a priori here, there's really no way of distinguishing the two. So we could use runtime warnings to try and convey some of this information, and the advantage that these have over the installation warnings is that they have context. So the user is actually doing something in the application when this screen is displayed. So they might have clicked something in Yelp to view restaurants near them, and so then when they get a request for Yelp is requesting location access, they have some idea of why Yelp is requesting location access. Likewise, if you're using Angry Birds and all of a sudden it requests location, it's not immediately obvious, and so maybe that's being used for something else. And then the user might have a better idea of why they want to decline giving it that access. Another nice thing about runtime warnings is that they can be dynamic. So in the case, here, maybe we have Bluetooth pairing. So in this case, because it's at runtime, we can show the name of the device that it's trying to pair with. Whereas if this were done at install time, basically, there's no way of doing that. You can't predict in the future what all the devices would be. These have drawbacks as well. So, the primary one is habituation. So users tend to see these as a barrier to the primary task. They're doing something, all of a sudden this dialog appeared. I need to swat this away so that I can continue doing what I was already, trying to do. So Microsoft got a lot of flack for this in Windows Vista. So they had this user account control. Whenever an application required any sort of elevated privileges, it would throw one of these runtime warnings and basically trained people to click continue whenever they saw one of these. So this begs the question, maybe we could use some sort of mechanism that doesn't interrupt the user's flow so that these aren't seen as a barrier to the primary task. So, one thing Apple's doing is curation. So in the iTunes store, when you download an app, there aren't any sort of permission requests because there's a screening process. If you're a developer, your app is reviewed by some sort of opaque process. And that's the problem is, Apple's goal is to try and review these to prevent, security and privacy issues for end users without asking end users to dedicate, effort to making decisions, often incorrectly, on their own. But the problem with this is that the process is completely opaque. So, it's relying on humans to do the review. They could automate this, but in a lot of the cases, these things are really hard to detect automatically. So there's some human review board, which of course, is then subject to human error, and some of it is, very subjective. So, people probably remember the Path fiasco, or fiascos, because this happened twice. Path is a popular social networking app. It turns out the iOS app, 3 years ago, was accessing users' address books on their iOS devices, which was against Apple's terms of service. Now, obviously, if it's against the terms of service, one would think that as part of the curation process, that would have been detected. It wasn't, and the app was used by millions of users. This happened again with Path a year or two ago. It was another thing that it was doing, which should have been caught by the review process, but wasn't. So there are problems with that. It's also resource intensive if you're hiring humans to be looking at millions of apps. So there are other approaches that don't involve the user being interrupted. So trusted UI is, when I say trusted UI, I mean system widgets that are drawn by the OS. So in this case, maybe for some ability, the developer specifies where on the screen a system-drawn widget should appear, such as a button or some sort of chooser. And then the only way of granting that ability is that through interacting with that system-drawn widget. In this case, a malicious app can't spoof that to try and get the permission because the spoofed one doesn't actually get the data. So, imagine sending SMS messages. If the only way of sending SMS on the platform is through this system-drawn button, it's relying on the user clicking on that button as part of their interaction with the application. It's not, interrupting them. It's part of the flow here. So, you can imagine other ones maybe with, for using the camera, there's a shutter button. And so then the only way of taking photos is by clicking that shutter button. Then it's part of the user's flow. There's no way of spoofing those buttons to capture the data anyway, and the user's not being interrupted. Another advantage of using trusted UI components is then granting subsets of the data. So you can have choosers. For instance, in this picture, we have maybe a calendar widget. An application wants to add something to the user's calendar. A chooser comes up. Now, it's not a binary choice. The user can, make adjustments before the data is accessed by the system. You can imagine things like this with, accessing photos in an application. And, this is nothing new. So we have this on, desktop operating systems. So usually when you open a file, those are, all those widgets are drawn by the OS. Developers don't usually implement the, the file open or file save widgets. These have, drawbacks though. So, in order to be, part of the user's flow, you can't have what I refer to as asynchronous requests. And what I mean is things that are triggered by the user's environment. So, imagine, you have some app for some Wi-Fi provider. Certainly you could have a button that issues a callback that says, when I'm within range, then join this network, but that's no longer part of the user's flow because now they're making a decision ahead of time. And obviously, if you're having them push the button frequently until they're within range, that's no longer, it's still not part of their natural flow. So this, there are some, limits to what trusted UI can be used for. And then finally, there's what I refer to as implicit access. So in some cases, maybe that the risk associated with a request is just so minimal, maybe it should just be granted without bothering the user. And in this case, we should have maybe some sort of attribution mechanism so that when permissions are granted automatically to minimize habituation, if something does go wrong, there should be information about what app was responsible, so provenance. So in this case, maybe changing the time on your device. You're not going to want to have like a runtime warning every time an app wants to maybe update the clock. You can think of some, James Bond-esque plot that relies on changing the time on someone's phone, but that seems really unrealistic. And in most cases, it's pretty benign, and the damage can be undone once it's identified. So in this case, maybe we could just annotate the settings panel to say what was the last application to modify that setting, so that if it's abused, someone knows which application is responsible, they can remove that application. So looking at all these permission granting mechanisms, if our utility function is to only interrupt the user when absolutely necessary, we can sort of build a hierarchy here. So least utility is the install time warning because users see these every single time. And the best case would be the implicit access where users aren't being asked at all to make any decisions. And I argue that one of the big problems that we see on platforms today is that most operating systems just pick one permission granting mechanism and roll with that one for all the decisions. So in the case of Android, it's all install time warnings. On iOS, they actually have, there are 5 current runtime warnings, and the rest is completely opaque to the user. But maybe we should choose which permission mechanism to use based on risk or something else. Researchers, people who are, I guess.
Because it seems like one of the problems here is that the developer's incentive is not necessarily the same as the user's.
Yes. Yes. That's a much broader question. I think that one of the big problems that we have is that, there are certainly mismatched incentives, which is a big issue. But I think one of the things that's really overlooked is that developers are under a lot of different constraints, and security is just a very small portion of that. And so frequently, they just want some sort of guidance on how to implement it. And right now, there's, we'll just make a warning and let the user deal with that. But I think that if there's, some guidance saying that this is, here are the current best practices, users will be more satisfied. And also, to some extent, the companies are sort of incentivized to do the right thing. So if, one platform has a reputation for apps, abusing data, then, they're going to take a hit on that. So it's in the company's best interest to keep their users happy and feel like, they're in control of how the personal information is shared.
Sure. Let me say, do you mean the company is the platform itself or the applications? Because
I'm talking about platforms.
Because applications and platforms don't always have the same
Agreed.
values or same interests in mind.
Agreed. Everything I'm talking about in this talk is at the platform level. I mean, so the platform can make these design decisions that, say the only way of getting access to this data is by using this mechanism. Then the application developers have no choice but to abide by that. Yeah. And so we reasoned about this, and we came up with this flowchart on how to make decisions about which permission granting mechanism to use based on risk and a few other things. So, the first step is this notion that we're calling revertibility. So if a device makes a change, can the device be reverted to a previously known good state? So maybe, one example of that is, say, changing the time. Obviously you can change the time back. Little harm is likely done. In that case, grant the permission, maybe have some attribution mechanism so that, users can undo it if it's abused. But maybe the damage can't be undone. So then the question is severity. So is this just an annoyance, or is there going to be some lasting harm by granting this permission automatically? And if it's really just an annoyance, so you can imagine something like maybe making noise or vibrating the device, you could probably think of all sorts of freak occurrences where that could cause lasting damage. But for the most part, that's just an annoyance, and once it stops, the harm is over. In that case, yeah, implicitly grant the permission and again have the attribution mechanism. But if none of that applied, then the question is, did the user initiate the action through their natural flow with the app? And if so, trusted UI component. If not, maybe it's something that's generated by the environment, one of these asynchronous requests. If a subset of the data can be, granted, or we can apply some sort of granularity to what's being requested, then you can have some sort of chooser widget from trusted UI as well. And if none of that applies, then the question is the permission needed in the future? If so, the only way of doing that would be at an install time. So a scenario there might be you have some security software so that if your phone is ever stolen, you can go to a website and it wipes the device. Obviously, you're not going to want to have some sort of runtime warning come up asking the person who now possesses your device if they really want to destroy the data on it. That has to be granted in the future. If it can be done at runtime, then have some sort of runtime warning or confirmation dialog. Otherwise, we're stuck doing it at install time. So going through the whole spectrum of different Android permissions, we can actually really reduce the number of user interactions here. So prior to applying this flowchart to the Android permission system, 100% of the abilities are granted at install time. But using this methodology, we can reduce that to about 6% of the permissions. And in fact, a majority of them could just be implicitly granted, and we can have some sort of attribution mechanism to tell users, this happened if you're interested. Of course, this is just looking at the total number of permissions, and this doesn't reflect how frequently each of these permissions are exercised. That's actually a project that we're working on this summer. We're hooking those APIs and actually logging them in the field to look at how frequently different permissions are requested on devices. So we can reduce a lot of these. And so the next part of the talk is looking at what are these attribution mechanisms that we might want to explore. So we're referring to this as begging forgiveness instead of asking for permission, because we're telling people after the fact what app was responsible for a particular change. So the question is, are these really necessary? Well, it turns out they are, because when we did an online survey and we asked people about how they'd go about pinpointing the cause of a misbehavior on their device, only 22% of our participants understood that applications running in the background could be just as responsible for a device misbehavior as applications running in the foreground. The corollary to this is the vast majority of users simply, when something misbehaves on their phone, they simply blame whichever app happened to be running in the foreground that they could actually see, which is probably likely to be incorrect.
They don't blame the OS?
No.
So that was just like Android's unreliable.
We asked, so it depends. I mean, so the scenario that we were asking about is like data overages, for instance. They would, they say, oh, well, I was using this app last, so that must be responsible. I'll get into that a little more later, but we didn't look at it from that perspective. When we asked about specific misbehaviors, I'm sure.
The answer is different when this has to do with like instability, like things crashing,
Yeah, I was gonna say,
setting,
yeah.
That's caused often by applications or drivers, but it's
No, I agree. That's not something we asked about. Yeah, I think instability is probably one issue. We were talking about, other things that could be controlled by the permission systems. So in answering,
If there's a different answer that people had found to that question on desktop OSs prior.
Which question?
about whether or not they blame the OS or the application due to something like.
Well, actually, yeah, I mean that's the point. So I guess before Microsoft, I guess this was, when did they start? Was it Patch Tuesday? That was like 10 years ago with the big trustworthy computing push. It was because the OS was getting blamed for instability, which was largely caused by poorly written device drivers written by third parties. I haven't done a direct comparison, so I can't really speak to that, but I can definitely say that from anecdotally on the desktop, people were much more, people would just blame the OS.
I'm sort of curious about whether or not the window, like the idea that on a desktop OS, it's natural that things are multitasking and they're visually taking up the space, are like simultaneously there versus on the phone and it's you're doing this one thing, whether that affects people.
That's a really good question. Yeah, we haven't explored that. So we wanted to look at, if we're going to start adding new attribution mechanisms to the OS, obviously we don't want to rely on a big, user education campaign because that's really costly, and really these would just be new features that appear in the OS. We want to see if users would discover these. And so to explore this, we looked at new features that have appeared in Android over the time to see how quickly users become aware of these types of audit mechanisms. So right at the time that we were doing this, Android 4 had been out for about a year, and it added this new feature for data usage. So in the settings panel, you can click this, and it brings up a panel. It shows the graph of your data usage over the past month. And if you scroll down, it'll show the applications by order of how much data they use. So this is not something that they were publicizing or training users on. And so we wanted to see, given that this has been in deployment for about a year, are users aware of this and would they take advantage of it? So, we provided a scenario and asked how they would, investigate a data overage, and we had an open-ended text box for them to describe what they would do on their device. And then we split people based on what OS they used on their device. And what we found was that almost 3/4 of people who had this feature were aware of it. They, in that open-ended text response, they succinctly described going into settings, clicking data usage, and investigating that way. People who didn't have this feature really had no idea. A lot of them, I guess over 20%, said that they would check the settings panel because they thought that would be an intuitive place for this, but unfortunately they didn't actually have that feature. A lot of other people said that they would call their provider or they would call Google or Apple, who obviously would have no idea, and those support calls are really costly. So clearly the platforms and the providers have an incentive to making this information accessible. And so the conclusion from this was that a lot of users, incorrectly or not, expect to see this type of information in the settings panels. And so that's useful for like one-time system changes where something in settings is modified. But what about ongoing misbehaviors? So imagine something like vibrating the phone constantly or playing music. Where do people look for those sort of things? So on Android, again, there's a notification bar. There is on iOS as well. In this case, you have this little icon that appears here, and users can expand that to yield more information. So here, it'll show you who the text from, the text message is from, and maybe what it says. And so the question is, are users aware of this feature, and do they know that they can go here to yield more information? Do they know to expand that? So we did a laboratory experiment where we basically implemented all these attribution features. So we did one in the settings panel and one in the notification bar in our experimental condition to provide attribution information for misbehaviors. And then we had a control condition, which just was a stock version of Android. Now it was double blind. We didn't know which phone people had until after the experiment. And so, as I said, we had an ongoing annoyance. In this case, it was vibration. So during the experiment, we had one application just start randomly vibrating the phone. Those in the experimental condition would see this icon appear, and if they expanded it, it would say which icon, which application it is. Otherwise, in the control condition, the only way of finding this information out is by going through the task list and killing each individual application until the misbehavior stops. When the phone stops vibrating, then it was probably the last application that you killed. For a one-time settings change, we modified the wallpaper. And Android actually has this, you can change it in two places. You can click on the background and then this widget pops up. And so we annotated that by adding this text here. So either by user or name of an application, or in the settings panel. So if you go through the settings panel to do this, we also added a text annotation there. Again, only in the experimental condition. In the control condition, there really is no way of determining what application is responsible if the wallpaper is to change. You can look through, like I showed you at the beginning, you can go through all your applications to see which ones have the ability, but if you have multiple applications with this ability installed on the device, there's really no way of knowing which was ultimately responsible. So the goal for the study was to see, given these annotations, whether participants would be able to correctly attribute the undesired behavior to a specific app. And also we designed the experiment so that they had several applications that were running in the background, all with the same permissions, so that any of them could have plausibly been responsible. So in our protocol, so we randomized the first two tasks and the second two tasks. I'm just showing these as an example. So in this iteration, maybe the wallpaper one was first and then the vibration. So we had it what we're calling implicitly first, which was we had it just happen without drawing any attention to it. And we told participants that they were there to review apps. And so we had them review 3 different drawing apps because each of them had the ability to change the wallpaper. And then we had them interact with a widget. And the reason why we had them do that is because then when they're interacting with the widget, they'd be able to see the desktop background so that when the wallpaper changed, they're likely to notice it. Since these phones required modifying the OS to implement all this stuff, we had to use our own phones that we provided to them. And so we figured that if if it changed between tasks and they didn't see it immediately change, they might not notice it, the background changed because it's not their phone. So, when we were examining that widget, we changed the background. We Biebered them. And then we looked at the reviews that we had them write for each of the applications to see if they mentioned this in any of their reviews, so whether they noticed it. And then without prompting them that we did this and that this was part of the experiment, we wanted to see if they would comment on it. And if they would, on their own, go through and use the attribution mechanisms and find them to try and identify the cause of this misbehavior. The second misbehavior was vibrating the device. So the other task was playing with 3 different timer apps. Timer apps because all of them requested the ability to vibrate the device. And then as part of the fourth thing they did after those 3 timer apps, play with the dice app. The reason for that was it was a dice app that they had to shake so that we could be assured that it was in their hands, and so they felt it when it started vibrating randomly. And again, we looked at the reviews to see if they noticed this on their own and used the attribution mechanisms on their own. After this, we did, explicit misbehaviors. We told them, you may have noticed this happened before. We're going to cause one of the apps to change the background. You have 5 minutes to go through and identify which app is responsible. So we did this in case, participants, either didn't notice it the first time or weren't sure. And then finally, we had an exit survey. So what we found was, for the vibration, in this case, there was a notification icon that appeared, and if they expanded that in the experimental condition, it would say the name of the app. And we found that, participants were significantly more likely to attribute the cause of this misbehavior correctly when they had those mechanisms. It was about 80% in the experimental condition compared to a little over 30% in the control. 30% seems pretty high, but given 4 apps, that's random guessing. And what we found was that 2 participants in the control condition actually did go through and kill every app until they found the one that stopped the vibration, which was actually a lot higher than we were expecting. We weren't expecting any people to know to do that, which was interesting. What was also interesting was that on all the devices, we instrumented the OS so that we knew exactly where they were clicking on the screen and what widgets they were interacting with, so that we could go back and check things like whether they expanded the notification drawer at the top. And what we found was that 90% of the people in the experimental condition did, but so did 70% of the people in the control condition. So they thought that looking up there might yield some information. So that suggests that where we put it for the other participants was a really intuitive spot. Just those in the control condition weren't able to find it there. Wallpaper change. So again, this was statistically significant, but it was only about 34% in the experimental condition noticed it, less than 8 in the control. The difference is, this is significantly lower than the random guessing because every participant saw this while they were looking at that widget. So most of them didn't randomly guess when they were wrong. They simply blamed the widget that they were using at the time that the misbehavior occurred. Yeah.
This is people able to identify that. Did everybody notice both in the?
Fewer people noticed it during the first task. So this was during the explicit misbehavior, when we told them, an app on your phone just changed the wallpaper, figure out which was responsible. Most people noticed it during the first task. They just didn't comment on it in their reviews because they weren't sure which was actually responsible. Many more people commented on the vibration task because they were using one of the apps when it started, yeah. So anyway, this wasn't random guessing. It was just blaming the widget because that's what they were doing. So most people just admitted to random guessing when they got it incorrect. What was interesting was that up to 20% of the participants simply inferred abilities based on UI features. So for instance, the wallpaper change, the application that was usually identified was one where participants somehow stumbled on a button for change wallpaper, and so figured, oh, because there's a button for change wallpaper, it must be this application because I didn't see that button in other ones. When really, the features aren't. An application's abilities don't necessarily correlate with the UI elements. The other thing that we had them do was, in the second time they did this, when we asked them to specifically identify an app, we also had them rate their confidence with, confidence in getting the correct answer on a 5-point Likert scale. And what we found was that, those in the experimental condition, not only were they more likely to be right, but they were also a lot more confident in those decisions. So even those in the control condition who managed to get it right did so with low confidence. So, this sort of confirmed our previous findings from the survey that, where we, put these things in the OS were intuitive to most participants. One question is, in the second task when they were doing the wallpaper thing, there was a significant difference, but it was only about 30% were able to correctly notice these attribution mechanisms. Should this be considered a success? I would argue that yes, because what we've seen in practice is that usually there are a small number of savvy users who tend to explore these sort of features, and then they're the ones who end up writing app reviews. And a lot of users put a lot of weight on the app reviews. So to give a good example of this, about a year or two ago, Instagram had changed their privacy policy to say that all photos that you upload are property of Instagram and can be used for advertising purposes. So literature over the past 20 years tells us that almost no one reads privacy policies. Yet, this was, in the New York Times the next day, and it was because there's a small number of people who do, and when they find something that's really, that really defies expectations, they disseminate that knowledge. And so, even though, only about a third of participants were able to use the attribution mechanism here, one that they had never seen before, which also might be part of the small effect. But if something truly bad's happening, then the few that are able to find these mechanisms will probably disseminate that to the larger public, the public at large. So the last part I want to talk about is when these decisions, when when the decision to confront the user with a permission request at runtime is necessary, how can we make those more informative? So this is actually work that I just presented at Chi. So what we looked at here was iOS. So iOS 6, which has been out for about a year now, added runtime permission requests for 5 different things. So any app that requests location, contacts, photos, calendars, or Bluetooth pairing, there's a runtime request like this that's shown the first time the app requests that ability. Once it's allowed, then the user never sees it again for that particular app. They can go to a settings panel to revisit that decision, but the app never bothers them again. What they added, though, over previous runtime warnings was the ability for developers to add a sentence here to explain to users why the data is needed. And there are actually no constraints on this. Developers can use this feature, they can opt not to use it, and they can supply whatever text they want. And so what we wanted to look at is whether having this information actually impacts user behavior. Are people more likely to grant permission requests when developers add this text here? And does the content of it actually matter? So given that developers have enormous freedom in terms of putting whatever text they want there, how much of a role does that have in users making the decisions about this? And so the next question is then adoption. So given that this has been available for about a year, how many apps are actually using it? And what are developers' perceptions? Why do they choose to use it? Why don't they use it? And when left to their own devices, what sort of text might they include? So we did an online experiment again where we showed people screenshots. We did a couple different variations of this, and so we had a control condition where we had a set of 12 applications, and applications that did have these strings, and we just photoshopped them out. We showed those to some people, and then we showed the ones with the strings to other people, and we asked whether they would approve the request. And what we found was that there was a statistically significant effect by having this text there. People were actually more likely to approve the requests. The effect size is relatively small, but there is an effect. We controlled for the order. So looking at when we did this within subjects, that didn't have any effect. And also app familiarity, since we wanted to use apps that actually use this feature. We asked people, whether they've used this app before, how much do they trust the app, and we actually found that that didn't correlate at all.
Sorry, did you write the text?
No. That's why we used existing apps, because we wanted to use text that was actually being used in the wild.
This makes me wonder how nonsensical it can get. Like these studies of the like the copy machine, right? Like, yeah.
Yeah. So I was actually going to end it on this. So there are a lot more details of the study which I could talk about. But we did a follow-up experiment where we actually did vary the information content. And what we found was that there was absolutely no effect based on the text that we included. They were, in every case, significantly more likely to approve it than in the control condition. So even in the no information case that we used was the app needs access to your contacts because it needs access to your contacts. No information beyond, not having that string there. Yet we found, a significant effect. And so, yeah, what we found, we found that this is probably the same effect as this famous study from the 70s, where they had people asking to cut in line at the copy machine and giving all sorts of excuses. So, and the control condition was, may I use the copy machine? But then they had this statement saying, because I need to make some copies, which doesn't offer any additional information over the control, yet people were significantly more likely to allow them to cut in line when they said, because I need to make some copies, which was actually indistinguishable for, providing a real excuse, so because I'm in a rush. And so this appears to be the same effect that we saw online, which is any explanation will do, and people are actually a lot more complicit when you give them something. We don't have a good explanation for why, but based on all of our results from that experiment, we have some suggestions. So one is that maybe instead of letting developers provide whatever explanation they want, we have some templates or a library. And so maybe at the time the developers upload their thing to the Apple Store, the iTunes Store, there's a questionnaire that multiple choice. Does the application use any of the following data? Does it use it for any of the following purposes? And so based on the responses to those questions, you can you can just automatically generate a statement. And the nice thing about that is that it's consistent over time. So the problem with letting them provide the text free form is that there are thousands of different ways of all saying the same thing. And so this way, by having the templates and having it machine generated, there might be some consistency, and then also avoids having this placebo condition of no real added information. And so with that, I will leave it there.
Great, thank you.
If you can go back to the Xerox and previous one, the one with the question, it's interesting because the Xerox discussion is among two people, right? It's not about me talking with the Xerox machine about me wanting to print more copies, right? I'm asking a fellow, a colleague, or someone else. Well, the example you gave is again, it's another corporation. It's an app developer. It's Facebook that's doing that. And in between, you have some type of regulation. They cannot write whatever they want. Sometimes they need to write something, or sometimes if they don't write, they explicit thing they wanted to say, the FTC can say, well, you are misleading.
Yeah, well, I think that part of this I think there might be some human element to this, which is given that developers write whatever they want here. So we built a corpus of over 4,000 apps. It's in the Kai paper, and we were extracting these strings from real apps and looking at the variety of different explanations in there. Obviously this probably correlates with the size of the company, but there were a lot of ones that clearly had no oversight. Things with typos in them, things that were just we suspect were a result of developers just not understanding the API correctly and having like code in there. And I suspect, though, that because there wasn't editorial, there wasn't any editorial oversight, that might have created more of a human element that this is a person who wrote this, as opposed to something in succinct. I was going to say succinct legalese, but that might be an oxymoron. Something that's heavily sanitized. Again, we don't have a good explanation for the effect, other than there was an effect. I think that might be part of it. I think another part of it might be simply, habituation. So maybe by having a wide variety of different ways of saying the same thing, each of these dialogues looks slightly different. So people may, pay more attention to them and are less likely to, click one button over the other. I don't know.
So I like the trusted UI thing, but one of the challenges I see is that it seems like it's going to be limiting flexibility and style for design. So if you look at a lot of apps, they're trying to have their own branding and their own style and be highly designed in some way. And as soon as you start imposing trusted UI on top of that, it makes it harder to customize that to the extent that the app wants to.
Agreed. Yes. That's something I'd like to explore at some point. We've been talking about that, looking at what the impact is on developers and developers' willingness to use trusted UI components. It's not something that we've looked at yet, but I agree that is an important point, and I think that's probably a big barrier somewhat to this.
I'm sorry to ask a question, but there's something I don't know. It's sort of an empirical question. It feels as if there are many different possible threats due to, say, permissions errors. And one approach is to sort of batten down the hatches and go after everything holistically. which is what you're suggesting, which I actually, the flowchart made a lot of sense to me. I like that quite a bit. The other would be to be a little bit more pragmatic. And in that sense, I'm wondering out loud, when you look at how people are abusing permissions errors today, how are they doing it? Like, what's the bulk of that permissions abuse? And is that something that could be special cased out and cut out 75% of the abuse without needing a top-down change?
Yes and no. I mean, so one, I guess no, because that's kind of a moving target.
That's fine if you're geometrically cutting out half of it every time.
It doesn't cut out half, it just might mean that half shifts to something else.
Right.
Maybe.
Yeah, I mean, so that's why I'd say no. On the other hand, I think the biggest problem that we see right now are just, I think the real issue here is looking at contextual integrity rather than just is this permission dangerous or not? Because that's not what we're doing right now. And I think looking at is the use of this permission going to be unexpected to this user? And if the answer is yes, then maybe we should warn them about it.
That's fine, but I'm trying to invent scenarios in which I would be upset if 25 text messages got sent out by an app. I mean, I can imagine situations where I download something and then it immediately messages my entire contact book. Like you have this in email, right, where occasionally I get phished or something. But to be honest with some of these things, I'm having trouble coming up with really deeply compelling threats. I mean, yes, you could share where I am with some potentially malicious group, but lots of companies already know where I am through my phone.
Yeah, actually, location. I didn't talk about it in here, but we did a lot of studies looking at risks and people's actual concerns over various things that could happen using their phone data. And we found that location is really towards the bottom of the list, which is interesting because if you look at, say, the privacy literature from the ubiquitous computing community over the past 20 years, location's the main thing that it's focused on. When in fact, I'm not saying that people don't care about location. I think that people still care about location, but relative to all of the other things that applications can be doing, location is a relatively minor concern. So.
Okay. So open question.
Yeah, I mean, so I guess what I was going to say is we've started looking at the contextual issue. I mean, so in the case of location, viewing Google Maps and getting a thing about permission request for location is stupid because you're habituating the user. When they're using a mapping application, of course they're expecting location. Whereas Angry Birds, then that's unexpected because it's being used for something other than in-app features. And so being able to disambiguate those cases, I think that's the next important step, is being able to determine what users will find unexpected just based on context. Which is something that we're not doing right now.
So the comment about only sending out 25 emails raised a small flag. For the individual computer owner, no, that's not a big deal. But that's exactly how spam bots work. There's many thousands of them, and each of them sends out some relatively small number. And so the role of your machine participating in a greater social ill becomes the problem. So it's not a problem to you.
Yeah,
it is for the
well, it could be. I mean, it still could be a problem for you. So the reason why a lot of this, I mean, the way that a lot of this malware is working is the ones that send the SMS messages, a lot of them are sending, premium SMS messages that charge, $50, $100 to your bill. They have those charity things where you send the, thing to make a donation. So a lot of malware, authors are using that to incur, thousands of dollars on people's phone bills, which might be, under 10 messages. Now, granted, if you call up the phone company and argue that it's fraudulent, you can probably get that reversed. But I think they're also relying on the fact that not everyone's going to do that. Yeah.
Bringing up maps in particular as an example and leaking location information, I'm wondering if there needs to be a place in this flowchart you had for focus as a means of granting permission, as opposed to just
What do you mean by focus?
So I'm fine with a map application or other applications which obviously need my location,
Yeah.
using my location when it has focus.
So we tried.
But it tracking me
I see what you
persistently is probably not what
You
I
mean
intend.
the fact that it's in the foreground?
Yeah. Sorry, focus in the UI sense.
Okay. I thought you meant something else, which is something we have looked at. I thought you meant focus as in that's the primary use for the application. That's the focus of the application is mapping. So one thing that we did do is we tried to train a classifier by looking at categories of apps and whether there are certain permissions that are indicative of those categories. And we actually found very unreliable correlations between categories of apps and the permissions that are requested. But that's something different. Yeah, I mean, at the same time, there are probably different reasons why having it requested in the background might be useful in some cases. So, for instance, caching. The GPS on your device is assisted because the chip by itself is pretty weak, and running on just the chip, sometimes can take minutes to get an accurate fix. And so some of the apps might be doing stuff in the background to try and fine-tune that so that the UI seems less laggy when it is at the foreground. That's one possible thing. I mean, I'm sure there are probably other scenarios.
So one other thought. You pointed out that curation doesn't scale.
Yeah.
And I think I see the point you're making, and yet way near the end of your talk, you made an observation that there's a small number of users who really care about these kinds of things.
Yeah.
And I wonder if that offers the solution to the scaling problem. That you could have the equivalent of a PolitiFact, basically out there, where the OS is essentially allowing the power users who really want to investigate these things to write, say, those description strings, or to offer pro-con for each permission.
Yeah, actually, that's something that we have talked about, is trying to crowdsource some of this by having, when there are runtime permissions, we then have a small sample of people that we then have a follow up to. Thing pops up and asks why do you believe it was requesting this? And then there's a feedback mechanism that puts the responses from that back into maybe reviews or some sort of quantifiable thing on the app download page that other users might be able to take into account when they're looking at the application. So when you see an application and it says that 90% of the users have no idea why it was requesting access to location or their address book.
Then, right? Like,
yeah.
Like then if the pop-up just says, why? And, if appcheck.com says, well, this seems questionable, or like that would probably have a major impact on behavior.
Yeah. There's been some work on that. I think it was Heather Lipford at UNC Charlotte built this system where they were providing these annotations for Facebook apps, basically showing how many people in their friend network have installed this or approve of this app, and they found that was actually really persuasive to people downloading apps.
Any other thoughts, questions? That's right.
With the whole idea that explanations are effective, I've seen some kind of weird / kind of maybe research-worthy questions in the intersection of that with the trusted UI components. I've seen some apps, including a couple made by friends actually, where they as developers want to be conscientious developers, and as part of their getting permissions, they want to, at runtime, have the little information string about why they're asking for it.
Yeah.
But most trusted UI components don't allow for inserting that string, potentially for security reasons, but I'm not sure why. But so they have to, they actually make it two dialogues, one that they control and one that if the user answers yes to that, they then pop up the trusted component, and have actually gotten flack for that from reviews because it's people see it as two dialogues stopping flow that they have to click through. Have you done any research into how to maybe streamline this idea of?
No, I mean, I could just say that we definitely observed that a lot of developers, not a lot, but when we built this corpus of apps that we were going through, we found that a lot of them have a secondary, well, I guess a primary dialogue that first comes up saying, that it's just a pop-up that the developer wrote saying, you're going to see a request for this, for your contacts. This is why, and it explains the reasons. And then when they click OK there, then they get the system-drawn one. I don't know how prevalent that practice is. We've certainly seen it. I don't know whether it's any more or less effective or, yeah.
I'm just kind of interested in from the developer perspective of, is there like a potential for a way to integrate the information line with the system-drawn dialogue, or is the security flaw potential there just too great?
Well, I think the issue there is that it's an annoyance because that's an additional, unexpected dialogue that's popping up, and I think that it points at this larger issue that, I guess those developers believe that they don't have the ability to put the pertinent information in these other dialogues, and so maybe that's that points to the design of the runtime dialogues.
All right. Let's thank our speaker one more time. Thanks, Serge.